shear force and the bending moment for last portion of the beam, which varies from x is equal to 3 to x is equal to 4.5 in this region. See, we are going from this region to this region. We are coming across this bending moment. When we move from one portion of the beam to another portion of the beam and we are coming across the bending moment, the value of the shear force will not change. Whatever is the value of the shear force on the left hand side of the moment, the same will be the value of the shear force on the right hand side of this bending moment. So the value of the V in this portion was -5. The value of the bending moment in this region will also be -5. So the value of the shear force on this side was -5. Therefore the value of the shear force on this side will also be -5. Therefore this shear force continues its travel from x is equal to 1.5 to x is equal to 3, from x is equal to 3 to x is equal to 4.5, and its value does not change. It continuously remains -5. So the value of the shear force continuously is how much? -5. This completes our shear force diagram. Now look at the bending moment diagram. Whatever is the bending moment on the left hand side, the same will be the bending moment on the right hand side, but provided we add the value of this bending moment, that is, as we are coming from one portion of the beam to another portion of the beam and we are crossing the point where the bending moment is acting, where the external moment is acting, that moment needs to be added. That moment needs to be added to the value of the bending moment on the left side of the beam to obtain the value of the bending moment on the right hand side of the beam. Now see, the equation for the bending moment on the left hand side of the beam was m is equal to -5x minus 37.5. So what we do to this is the value of the bending moment on the left hand side. This is the equation. This is the equation for the bending moment on the left hand side. This is the equation for the bending moment applicable on this section of the beam. Now we are moving from this section to this section and we are coming across this bending moment. This bending moment is clockwise. Therefore the equation for bending moment in this span will be same as the value of the bending moment as the equation of the bending moment on this side of the beam, plus 60 kilonewton meter is to be added. So the equation will be -5x minus 37.5 plus 60. That's what we are doing. So if you do it, the bending moment equation m will be equal to -5x plus 22.5. This is the equation for bending moment on the last portion of the beam. Now as we plot this, you will obtain a curve, a straight line. You will obtain a straight line. At x is equal to 3, the value of bending moment is at x is equal to 3, the value of the bending moment is 52.5. At x is equal to 4.5, the value of bending moment is 12.5, and it will be a straight line because this equation governing the bending moment in the last portion is also a straight line. So this completes this is the shear force diagram for the beam. This is the bending moment diagram for the beam. You can solve this problem without making use of these equations. dv by dx is equal to -w or dm by dx is equal to v. Without making use of these equations, you can also solve this beam. For that purpose, you have to take the sections as we have already discussed. Thank you.